In this example, we'll take a look at resampling again, but we'll look at choosing a resolution for your Lidar data and resampling from there. We talked about in previous videos and previous exercises about the importance of choosing a resolution for your data, that we first think about the phenomenon we're studying and then we look at the available data. One of the benefits is if you have Lidar data, for here we're looking at elevation data, display of Lidar data in Zion National Park. If you have Lidar data, one of the benefits is that we have the option to use the coarser resolution. So we have a lot more flexibility. We can look through the metadata that comes with the Lidar point data sets and get an understanding of what the best accuracy is. And for this Zion data, the best accuracy, or they recommend a DEM resolution of no smaller than 1 meter. You can find, depending on who collects it and how they collect it, you can find finer scale Lidar data, but this is what's freely available, so this is what we're sticking with. So with this Lidar data, we have two options. If we don't know what our other data sets will be, we can just go ahead and convert this from an LAS data set to a raster data set, like you'll do in your lab, using that 1 meter cell size as our output. So we can use our LAS dataset input, we can rename it if we wanted to, we keep the elevation and all these other defaults. We definitely want a floating point as our data type because we do have fractions, or we don't have whole numbers, I should say. We're going to keep our sampling type as cell size. This is what sets it up for defining the resolution of the output. And we can go ahead and change it to a 1 meter. And I'll go ahead and click on run. And this will take a couple minutes, but while it's running, the reason we chose that 1 grid cell size is because that's what we found in our metadata, and we do have that flexibility with Lidar data. So we can start here with our 1 meter data. Let me turn the point clouds off. And essentially go from here, knowing that, we have the option. We've put it in the finest resolution we can. We now have the option to display it, or to resample to a coarser resolution. Let me put an elevation in here so it makes a little more sense. Okay, so we can see a couple issues with this data, but it does give us that really fine 1 meter grid cell size to really give us an overview of the elevation and topography of this area. Let's say we find out that we don't need data to be this fine scale, that we can use a coarser scale. Same thing we did before. We just head over to that resample tool. We'll pull in our Zion data set, and we can change that output cell size to 10 to 30, whatever we want to look at. So before I do that, let's pull up the metadata and see how many rows we have here. Oops. So here we have 1500 by 1500 at that 1 meter cell size, so a lot smaller area than we see in our other examples. So it's 2,250,000 cells. So we can go in here, we can resample it, we'll change it to bilinear again, and we'll click run. So we can immediately see that we've resampled, that we're at these 30 meter grid cells. Our data is a lot coarser. We don't have that smooth terrain as we did before. And we can pull up our properties, check out the raster information, and now we only have 2,500 cells. So again, a lot smaller area, 50 cells by 50 cells, and we're getting a lot coarser information on the elevation. So again, that's a choice, how we would resample Lidar data. You could, of course, start from converting. You can convert immediately to a 30 meter grid cell size if you know you don't need let me turn this off. If we knew we needed 30 meters right away, we could go ahead and just convert from LAS dataset to raster at the 30 meter cell size. For this option, it was sort of like we weren't quite sure what we needed. We thought we'd go with the finest just in case we could find finer scale data to use. So I won't demo that, but it's basically you would just change our sampling value to that 30 when you use LAS to raster tool.